Hello everyone, welcome back to Z Physics. Today we are going to be talking about intensity. Now, what is intensity? Intensity is defined as the total power transmitted by an object per unit cross-sectional area. So, in other words, we can think of intensity, normally given the symbol I, as the total power per unit area. The units of intensity are watts per square meter, and because power is defined as the total energy that has been transmitted outwards per unit time, we could also write down the equation for intensity as energy divided by time multiplied by the cross-sectional area. Now that we know what intensity is, let's apply this at quite a typical problem. We have a little light bulb over here. You can see my artistic impression of a light bulb. And what I want you guys to do is to calculate the intensity of this 50-watt light bulb at a distance of 20 centimeters away from it. Now let's have a look at the solution. The trick to those type of questions, anytime we need to find the intensity or we are given the intensity at a certain distance, is to think how light spreads from a point source. And a light bulb or even a star, we can actually assume to be a point source. The light is going to be spreading in the form of a sphere around this light bulb, and the radius of this sphere will be equal to the distance that we are interested in. This means that any point along the circumference of this circle will be receiving the same intensity. In fact, if you imagine this to be three-dimensional, any point on the surface of a sphere of radius, let's call it r in general, not just 0.2 meters, is going to get the same intensity. We can write this as the intensity being equal to the power divided by the cross-sectional area. Now, because we are actually dealing with a sphere around our point light source, we can say that the surface area is equal to the surface area of a sphere. So this means that the intensity will be equal to the power transmitted divided by 4 pi r squared. Remember, 4 pi r squared is equal to the cross-sectional area of a sphere. So let's put in some numbers. The intensity in this case was 50 watts, like so. We're going to divide that by 4 pi, and our radius is equal to 0.2 squared. One of the most common mistakes here is to forget to square the distance, but we're not going to do that. And if we put this into a scientific calculator, we are going to get 99.5 watts per square meter. Let's call it about 100 watts per square meter. Now notice that any point on the surface of this sphere is going to be getting the same intensity, the same amount of joules per second per square meter. So that means that this point here will also get the same intensity, about 100 watts per square meter, and also this point here will also be getting about 100 watts per square meter, and all of the points along the surface. If we make the radius of the sphere smaller, then the intensity is going to rise. We can see that because if this decreases, the intensity is going to increase. Additionally, on the other hand, if we were to bring the point further away, so let's say we expand it up to Here, the intensity is going to decrease. That's because I is directly proportional to 1 over r squared. Okay, folks, so hopefully you've enjoyed this video. If there are any questions about intensity or intensity at a distance r, do not hesitate to leave a comment. Thank you very much for watching, and see you in the next video.